To figure out what the slope parameter is, it's helpful to know the definition of the slope. The slope for a linear relationship is equal to a ratio, and the ratio is how much does the y variable change divided by how much does the x variable change. And I'm just using the lower Greek letter delta to represent change. So it's the change in y divided by the change in x. I can often see that quite nicely on a graph. If I look at this graph, this point and this point are very convenient for figuring out both the change in y and the change in x. If I look at this, I can see that my y variable is changing by this much. In fact, I would say that my y value is going down by 2 units. And I can also see that my x variable is changing. X is over here at -5, and it ends up going all the way to 0. So I can also see here my x is changing. Yeah, my x is changing from -5 to 0 is 1, 2, 3, 4, 5. So this is changing by 5 units. So now that I know both my change in y, right, y is changing by going down by 2, and I know the change in x, it's going up by 5, I can write the slope. The slope for this line is equal to -2 over 5. Here's another example. If I'd like to find the slope of this line, it's a good idea to identify some points where we can see that it's clearly crossing. So for example, it looks like 3, 4 is a value on this graph, and it also looks like 6, 5 is a value. When I give this function the number 6, it will return 5, and if I give this function the value 3, it looks like it will return 4. So I can see those values. So in this case, it looks like my y's are increasing by 1 unit. So I can say my delta y is going up by 1 unit. And then my x values look like they're increasing 1, 2, 3 units. So I could say delta x is 3 units. And again, because the slope ratio, SLOPE, is equal to the change in the y divided by the change in the x, we would say here our slope is 1/3. And we'll look at a final example. So find the slope of this line. Let me zoom in here. It appears that I've got some nice points living right about here. Whoops. And right about here. And in fact, I can say that it looks like my y variable is changing by 1, 2, 3, 4 units. It looks like this is a change of 4 units, and I'm just going to say I'm going down by 4, so I'll say down by 4, -4, and my x value is changing just by increasing by 1, so this is +1. So again, my slope ratio, delta y over delta x, I can see that my y variable up and down is changing by, it's going down by 4 units, and my x value is changing by increasing by 1. So if I was to ask to simplify this completely, if I have a denominator of 1, I wouldn't end up writing that. I would just say that my slope is equal to -4. And that just implies that I'm going to go down 4 units and over 1, down 4 units and over 1. And you can see that pattern repeats itself continuously. So starting at this point, I could go down 1, 2, 3, 4 units, and then just over 1. In fact, I've got enough room that I could do it again. I could go down 1, 2, 3, 4 units, and over 1. All right, so that's finding slope from a graph.